and easy marks that Mr. Myers is offering to me. What is 3? A, as in the grade you are going to get because you are paying attention in class. 4. F, because you are fantastic math students. Oh, wait. Oh, no, that's wrong. And the first one is an H, you clowns. The first one is F. The fourth one is H. 5. C, as in math is cool. 6. G, as in great. I'm spending another 80 minutes in math class. 7. E, as in excellent. More math. Out of 7. Jacqueline. I can't hear you, Jacqueline. Give me one moment while I discipline these people over here. Discipline, discipline, discipline. No, you're not. You're a liar. And you're not even good at it. But you will be done very soon unless you figure out where my line is. Okay. We'll see. Jacqueline? Where? Which numbers, Jacqueline? 2. A number that can be expressed as a product of 3 equal factors. Yes, is not a cubed root. It is the perfect cube. You guys. Man, obviously I have to stop listening to you.
Why did you correct us the first time?
Because I expected you to get the multiple choice part right.
He is so I knew that for like the last part of my day.
Wow, I was almost asleep, you guys. Take it easy. Wow. B. Can you read your email?
Which one? I stopped.
I mean, like, dude, right?
Yeah,
I'm not riding the bus.
He's got too much time on his hands.
Yeah, I'm like, dude, how can I be a bus captain?
Yeah.
I'm going to just mail in, okay, go get on the bus, done.
Why do we need a bus captain? The people going on that bus are...
It's like, serious.
I don't think it'll be a problem.
Wow.
Whatever, what are you going to do?
I'm out, right? Now, I think we got trashed a few times in an email.
Yeah, I don't care.
Nobody reads it anyway.
No one reads it. All right, number 8. D, and that is actually correct. Number 9. That is correct. Number 10. That is correct. Number 11. That is correct. Number 12. C.
I got it wrong.
Number 13. Yeah, I'll allow it because that's the best answer that's up there. 14.
Not even an answer.
I will accept B, but the better answer is F.
Yeah.
I got the answer right.
Yes. No, because the product of 1 and a radical is 1 root 7, but we don't write the 1. You want that mark, Amelia? You take that mark. What is the proper answer here? Add. I will accept those of you that insist on using bad grammar who will say you plus the exponents. Don't laugh. I guarantee somebody has written plus the exponents here. What do I do here? I multiply. I guarantee you a bunch of you have timesed it. Just like, who are we versing today in soccer? Who are we playing against? Versing is not a word. Versing, you could argue, is writing poetry maybe, because poetry is comprised of verses.
So it's not in the dictionary?
No.
Are you sure about that?
Yes.
Like versing, like we...
That's not a word.
It's not.
No, but like, what if you say like this team versus?
That's not versing, is it? That is versus, not versing. And what is 3? 0. Making this page out of 17. Number 4. The real word is reciprocal. But a great many of you will say, I do not know that word, even though I used it a million times. So I will accept flip. I will accept some people actually drew a fraction and drew some arrows to show it was turning over. Anything like that. This is square root of 15. This is 4 to the 5th. This is 7. This, no. This is not elementary school. I am not going to take a mark off because you forgot to write centimeters. This is -3. This is 4 cubed root 405. Or fourth root. Fourth root 405. And this is very tricky, is m to the 2/3 over n. And that's it. Now, stop. In an orderly fashion, ask any questions that you have. Gersahil. Number 10. Yes. So, that is a cubed root, which means you have m squared over n cubed to the 1/3. What do you do with exponents over brackets? You multiply them. M to the 2/3 over n to the 3/3, which is 1, which we don't write. 1, 2, 3, 4, 5, 6, 7. Another 7 marks there. All right. Now we are into the more subjective ones. You may have different work than me, so what you are looking for now is the right answer. 9,604, of course, divides by 2 to get 4,802, which of course divides by 2 to get 2,002 and 2,401. 2. Now that gets a little snaky now, because it doesn't divide by something until, if I'm not mistaken, it is 14? 7. Pardon? 7 and 343. So yeah, 14 would have worked. And then 343 is 7 times 49, which is 7 times 7. So the prime factorization is 2 squared times 7 to the 4th. I would also, of course, accept 2 times 2 times 7 times 7 times 7 times 7. Both of those are acceptable, and you will give yourselves 2 marks. Now, some of you don't like factor trees. That's okay. You could have done the ladder method, which I never showed you, but some of you do know it. Simrith.
I did the radican and then I did 90 and...
I'm sorry, what? Pardon? You did.
How about 90?
Yeah, but... Oh, right. Sorry, it does say evaluate. Yes. So then, of course, you would finish this up by bringing out 2 and 7 squared and get 98. Yes, thank you. That is the first half. I forgot that it actually said evaluate. So, of course, you would bring out a 2 and 2 7s, and the answer is actually 98. Thank you. These questions, I don't really know. A lot of people were asking about them. I was a little bit confused. Square A is how big? Each side is 5.1. So what is the area of square A?
20.4.
You could have written 20.4, but the question said I wanted exponents. So it would have been better to write 5.1 squared plus, what was B? 3.5 squared. That's all you had to do. Just write the expression. Oh, and evaluate. Oh, no. So, yeah. And what was 3.5 squared? You used your calculator to get it, whatever it was.
6.
How much?
13.6.
And your answer was, of course, 33. Ooh, I lie. 34. Exactly. Well, Emma told me 20.4 was 5.1 squared was 20.4. Well,
26.0.
Liar.
so the answer is, and is 3.5 13.6?
Probably not.
To get 38.26. Now, Emma, if you wrote 5.1 squared and 3.5 squared, you would still get credit. Because that was half of the job. Right? Well, you would get 1 out of 2 because it's out of 2. Same thing here. 4.3 squared plus 9.3 squared gets you whatever the answer is. Now, the answer has to be somewhere around 18 and 85, somewhere around 103. But I don't know because I'm not getting my calculator out to do that. 104.98. Okay. Out of 2. Then this question, again, there's lots of ways you can do it. So again, just bear with me if you don't have what I have. I would do all of this first because I don't want to bring that 2 to all of these variables. So I would go a squared and a is a cubed. B and b cubed is b to the 4th. C to the 4th and c squared is c to the 6th. Then I would come down here and I would have b to the 6th and c to the 15th. The top is squared, so now I only have to bring that 2 to 3 variables. A to the 6th, b to the 8th, c to the 12th, over b to the 6th, c to the 15th. Is there any a's on the bottom? No, so a doesn't change. Are there any b's on the bottom and top? Yes, there are 6 on the bottom. There are 8 on the top. They are both positive. So is anybody moving? No. So I can just get rid of those 6. And how many of these?
2.
There's going to be 2 left because I can get rid of 6 of them. So b squared. What about here? Are they both positive?
Yes.
So I can cancel those 12. How many of those? How many of those disappear? 12, leaving me with how many? 3. Final answer out of 2. Gersahil.
But for C12 to the 12 and C to the 15, what gives them past 12 or 15?
Okay, what is 12 minus 15?
Negative.
Where do negative exponents go?
Oh, I see.
Is it a 14 or 15?
That page is out of 2, 4, 6, 8, and 7 is 15. Now, I was tricky here. I changed it from biggest to smallest. Oh, Mr. Myers, you meanie. So, what did you have to do here? Well, root 30 was already good. What did you have to do with 4 root 4?
What was the previous page out again?
15. What did you have to do with 4 root 4? Did a question exactly like this in our notes. What should I have done here? Amelia? You could have put the 4 under there and gotten root 64. And what do you do with the 3? So that would have been root 54. And what is the problem here? It's a cube root, right? So this would have been the cubed root of 40. Now you're in a bit of trouble because the cubed root of 40 doesn't work with the rest of these, does it? What's the square root of 30? Approximately. What perfect square is near 30? 6 or 6 or 5, right? It's almost halfway between 25 and 36, right? So that's about 5.5. What's square root of 64? Square root of 64. 8. Okay, so which is bigger, root 30 or root 64? Obviously root 64. They're both roots. Root 54, still a square root. So these two are easy to put in order. What's the biggest? Root 64, and then root 54, and then root 30. Where does this guy fit in? It's a cubed root of 40. What are my cube roots? What's a cubed root of 8? 2. What's the cubed root of 27? What's the cubed root of 64? 4. So this is between 3 and 4, isn't it? Well, I know that was 5-ish. So that must be the littlest one, right? Then you just put them in order. Out of 2. Describe the method you used, whatever you did. Some of you may have estimated. Some of you may have put them into entire radicals. Some of you may have just gotten out your calculator and gone 2 cube root 5 and written down the estimates. Whatever method you choose. Who are we versing today? Whatever method you chose, you were supposed to tell me about it. That is, of course, 9 times 5, 3 root 5. That is, of course, 8 times 5, 2 cube root 5. And that is, of course, barfy, 3 times 81. So it is 9 root 3. Of course, if you don't have your perfect squares memorized, what did you have to do with all of those? Factor trees or the ladder factoring. I work with weird people. Express each radical as a power. Where does the index go if I want a power? Denominator. Where does the power go? Numerator. Where does the radicand go? Base. Done. What is the index here that we don't write? 2. What is the power here that we don't write? 1. So that is x to the 4th over y cubed to what power? 1/2. If you have that, you get full credit. Could you make it better? Yes. X squared over y to the 3/2. I would accept either one. All of these are worth 2. Oh, barf-tastic. What does the radicand become? The base. What is the exponent? One. And the denominator? The denominator? 3. If you have that, you get your full 2. But you could also have written that as 4n to the 4/3. Does everybody know why? 64 to the 1/3, that's the same as the cubed root of 64, which is 4. N to the 4th, 4 times 1/3 is 4/3. I would have accepted either one. I am betting not very many people have either of those. But if they did, boy, would I be happy if I was marking their tests.
I got 64 and 4 to the thirds, which is very low.
No. If you told me it was 64 n to the 4/3, I would still give you 1 out of 2. Yes. Because all that says to me is you forgot that 1/3 still has to go to the 64. Because this, it's all the base, right?
And then for B, I got x 4 to the power of 2. Wait, no. I got x 4 over 2 and then over y 4 over 2.
But y was cubed.
Yeah,
It's okay, so you'd still take 1.
okay.
I am not unreasonable, ladies and gentlemen. Were these on your guys' pages?
No, we had the dice.
No, you had the dice question, right? So, obviously, duh, forget about those. Now, the dice question is 2 ways you could read it, right? There's 8 contestants, yeah? So if everybody has their own die, there's 1 roll. How many people are out of the game?
4.
Half of them, right? So in the first roll, we'd be down to 4. On the second roll, what would we be down to? 2. On the third roll, what would we be down to?
1.
A winner. So there are 3 turns, it should have said. Now, if you're counting rolls, how many people rolled in the first round? 8. How many people rolled in the second round? 4. How many people rolled in the third round? 2 to get 14. I would accept either answer. Okay? Now, which one makes more sense for the unit we're studying?
The other one.
This one, because it's a cube root, right? Huh? Let's see what the page is out of. Page is out of 2, 4, 6, 8, 10, 12, 14, 16. Everything's worth 2. All right. Let's see how Amy did. For 2 marks, you have to find her error. Is it here? No, because negative 1/4 is negative 0.25, right? So she's okay. Let's check the red line. Is that okay? No, why not? Addison. Oh, yeah, Addison. She's adding. It should have been negative 0.25 minus negative 0.75. No negative there. So there is her mistake. She added 2 negatives instead of what she should have done, which was subtracted. Right? Mm-hmm. But she didn't. She left it as negative. She went plus a negative. So that gets you 2 for finding a mistake. And the real answer is 0.25 plus 0.75 is what? Positive 0.5. So it was 3 to the 1/2, which I would accept. What's a better way to write it? Because 3 to the 1/2 doesn't really make sense. Square root of 3. But I would accept that. I would accept that. I would even accept that. Why does this make no sense and this doesn't really make sense? Why is this the best answer, Jacqueline? Oh, you have a different question. Go ahead. No, Jacqueline, because those are the base. Just like if we had x squared over x, that is xx over x. One of them cancels, right? But I had 3 to the 1/4. Oh, sorry. That's the x squared over x, you would do x to the 2 minus 1, right? Because the x is the base. Well, the base here is 3. So you got to leave the 3. The base doesn't disappear.
So is that a 4?
That one's out of 4. Now, anyway, as I was saying, why is that... Why is that the answer that I seek there as the best answer? Jiddu. Yeah, because this, if I ask you to explain this to me, can you write the base of 3 multiplying it by itself half a time? No. We all know what 3 squared is. That's 3 times 3. We can all explain why 3 to the negative 2 is 1 over 3 times 3. But this, you can't explain. So that's why that's the best answer. Yeah? Making that page out of 4. So we have 20, 35, and 17 is 52. And I will be coming around for that today, hopefully. But if I don't, tomorrow when you write your test, you will write your score out of 52 right on the test. Okay? Take your time to add her all up. 52. Well, what happens to class when you are absent? If you were not here, I give you an omit and it doesn't hurt you, but it also didn't help you. Jezri.
Yeah, for this one, aren't you supposed to write it as a power of 4?
Yeah. So 4 to a power needs an exponent. That is a power of 4. Period. Of course.
So would that still be acceptable?
No, because that's telling me you want the 4th root of 4, which doesn't exist.
Okay.
So you lost a mark.
Okay.
It's no big deal, though.
For this one, I put like the index C instead of like writing it. Okay.
Right. We are on page... It's not 119 for you. No. We are on page 52. No, I lied. Well, 52 is the outline. 53 is the work. Okay. Not being your grade 9 teachers, I have no idea how in-depth they went on polynomials. So I am starting from a basis of 0 knowledge of polynomials. Not that you have 0 knowledge of polynomials. You all have a lot of knowledge of polynomials. But I'm going to start as if you had none. So let us begin. A polynomial is a math, and I'm not going to write mathematical because I'm lazy. A math expression using some combination of, and I'm going to use different colors here, coefficients, variables, and constants. I forgot the N. Constants. Now, a lot of kids mix up coefficients and constants because they look exactly the same, okay? So I'm going to write out one polynomial using those colors. 4q plus 7. All right? The 4 is a coefficient. Because what does a coefficient do? Coefficients work with, I shouldn't say variables. Coefficients multiply. A coefficient will change the value of the next thing. Everybody cool? A variable is any unknown. What do we usually use in math to show an unknown value? Any letter, right? But does it always have to be a letter? What do we use? Anything that isn't a number. Everybody understand? Like if I said for blank, do you know what I'm thinking of right there? So that blank is technically a variable. Is everybody good with that? Spectacular. And of course, constants are simply numbers that stand alone. Why are they called constants? Because that guy is always 7. Okay? Unless there's a coefficient in front of it, because a coefficient is going to change the value of the 7. Everybody good? Spectacular. A monomial is any single CV or C. Coefficient variable or constant. Please underline single. Connected by multiplication. And it's weird to discuss it in words, but it's easy to see it in numbers. Okay? I'll use my colors. 4. Is that a monomial? Is that a single coefficient variable or constant? Yes or no? Yes, it's there. There's only one thing. It's a single constant. Okay? Connected by multiplication. Everybody cool? Okay. What about this one? 4m. Is that a monomial? Yes, because it is a coefficient and a variable connected by multiplication. So that is still a monomial. Everybody still good? Okay. Now this is the one that screws kids up. 4ABC. Still a monomial. Why? Even though there's 4 things in that, it's still a monomial. Why? Why is this one still a monomial? Because it's all connected by multiplication. Everybody good? We're all cool, yeah? All right, now you're intelligent young people. A monomial, mono, 1. Binomial, 2 monomials. Connected by what?
Addition.
By addition. And of course, addition automatically includes what? Subtraction, because subtraction doesn't really exist, right? It's adding negatives. So, 2 minus, this is tricky, 2 minus 6, would you call that a binomial? Oh, I should have used green there. Would you call that a binomial? Yeah, but would you ever leave it as a binomial? Because what is it really? -4, right? That's a tricky one. What about this one? 4 x plus 6x. Would you call that a binomial? But would you ever leave it that way? No. Okay. What if I added a squared? Is that now a binomial? Yes. Because coefficient, variable, and the squared just means xx, doesn't it, Jade? So it's still connected by multiplying. So that's why that is a binomial. Everybody good? Okay, what about this? 4abc plus 7. Yes. Monomial, because it's all connected by multiplication. Monomial, because it's just a single constant connected by addition. Could any of these plus signs be negative signs and still be a binomial? Yes. Everyone is good? Obviously, what is the definition of a trinomial? 3 what? 3 monomials. It's a hard word to say, I'm with you. 3 monomials. Right? And everybody can come up with an example. I'm not even going to use colors anymore. X squared plus 7x plus 3. Right? 4a, b, c, d, e, f plus 3 h, i, j, k, l plus 2. Still, no, you don't have to write it down. Finish what?
The alphabet.
No.
Please.
No. No. No one's going to write it down anyway.
I will if you write it.
You guys are liars. Yeah, okay. All right. Okay. So, please notice how little white space I am leaving here. If I don't leave a lot of white space, is that concept particularly important? No. For some reason, people get really up in arms about the degree of polynomials. There is nothing to worry about. Okay, I'm going to show you once, and then you're promptly going to forget it, and I don't even care. Okay? The degree of polynomials, and this is a tricky one, the way it's worded, is the sum. What math gets us a sum? Addition. The sum of the exponents in any one monomial. What? Again, it's always easier to see if we show it. 4x plus 2. Mono, bi, or trinomial? Binomial. 4x plus 2, right? What is the exponent? Some of the exponents. I forgot. Some of the exponents of variables. Sorry, everyone. What is the only variable in that whole polynomial? X. And what's its exponent, Jaden? 1. So add up all the exponents with variables there. It's 1 plus nothing, right? So that is what we call a first degree, because it only has 1. Everybody cool? And what if I did this? 4xy. What are the exponents there? What are the exponents there? 1 and 1, which we add to make 2. So this is a second degree. Everybody good? Okay. What then would this one be? 4x squared y squared. What's that one? Fourth degree. Now there's one other little wrinkle here. It's the sum of the exponents in any one monomial, but it also needs to be the largest. So what if I added 3xy? What is this guy's degree? 4, because 2 plus 2. What is this guy's degree? 2, because 1 plus 1. So this still is a 4th degree polynomial. Everybody understand? Good. Now, and make it follow your ear, because it doesn't matter. Okay? Okay. The only reason it matters is when polynomials get really complicated, we like to write them in an order. But our polynomials are never going to get that complicated, so don't worry about it. Got it? Okay. How many of you have seen, we are not going to do the first thing, but we are going to draw it. How many of you have seen these? What does that represent as a number? Positive 1. What does that represent as a number? Negative 1. What do they represent together? 0. Excellent. Now, what if I drew a bar that was not, no. 1, 2, is it quite 3? It's not quite 3, is it? So can you tell me an exact value for that length? So since you don't know exactly what it is, what do we give it in math? We don't know what it is. That is an x. No, we give it a variable because it's unknown. So what do I give that? Negative x. And what would happen if I put them together? 0. And then finally, what if I took this bar and I stretched it? Ruined my magic. Magic doesn't exist. Now the eraser's not working. What a piece of garbage. What if I took that and stretched it that way? Yeah. How long is it sideways?
Like 2.
Pretend it's exactly the same. X. How long is it up and down?
X.
Well, then how big is that?
X.
X what? X squared. Which makes that what? Negative x squared. Now, these things are very, very sexy in teaching math right now. Everybody loves them. They're like, it really helps kids understand. It is very useful as long as the exponents never go over 2. Oh, but they kind of do a lot, don't they? And it's really useful if we don't have negative exponents, except we do, don't we? And it's really helpful. What it is really helpful for is teaching you why subtracting a negative is the same as adding. That's what it's really useful for. But I'm supposed to show it to you because you're supposed to be able to understand what is actually happening with the numbers. So, we're going to work with this right here. 5 is the monomial, isn't it? Because it's single. X plus 1 is the binomial, isn't it? Because it's got 2 terms. So in English, as a sentence, what would you say that highlighted math would be? How would you say that to me? Yeah, that's I know it's a math equation, but how would you say that to me? 5 times x plus 1. Easy peasy lemon squeezy, right? Nice job. So, if I need 5 times x plus 1 and I want to draw it, how do I draw x? I draw a bar, right? How do I draw plus 1? The little square. And how many of them do I need? 5. Because it says 5 times x plus 1. Well, how many times have I drawn it? Once. So how many times do I need to draw it? 4 more times to get to a total of 5. Easy peasy, right? Okay, so I'm not going to draw it 5 more times. I need you to show it to you twice. 5 times that. So I got 5 is one of my factors, yes? Because it's 5 times something. So I'm going to draw 5 little guys, right? And then I also need to draw x plus 1. And then I can make this sassy little rectangle. 1, 2, because that distance, 1, stretched x times. And then 1, 2, 3, 4, 5. Here is the 5. Here is the x plus 1. So what must this be? If that's a factor and that's a factor, what is the green part? What do you get when you put 2 factors together? No. You get a product, and the product is the answer.
Excuse this interruption, please. Can I have the owner of a white Mustang license plate JH257C? That's a white Mustang JH257C. Please come down to the office. Thank you.
Everybody see how you can just find the answer by counting up in the middle of the rectangle. Everybody good? I'm only going to make you do this like 5 times all year, and then you're never going to need to do it again. Now, this is what we call pictorially. Algebraically means we are going to use numbers. And numbers are just symbols. Because a symbol represents something else, right? How many fingers am I holding up?
4, 5.
Don't do that. Your thumb's a finger. It's got 3 joints. How many fingers am I holding up?
5.
5, absolutely. But what would you write on your piece of paper if I told you how many fingers I'm holding up? What would you write right here? You would write a number 5, right?
Yes. Which
Which is kind of weird because that single thing represents 5 things, right?
Yes.
1 there, and 1 there, where it attaches to your wrist.
Yes.
Yes. Does it move?
Yes, joint.
It's a joint. (5x plus 1). Now, ladies and gentlemen, if there was no plus 1 there, how do we write this? How do we write this? 5x. If there was no x there and there was a plus 1, how would we write that? Plus 5. So all that does is give us the distributive property. The 5 multiplies to everything inside, which we have already used in exponents. So I get 5 times x plus 5 times 1, which is indeed 5x plus 5. Everyone is good? Now, the thing about the distributive property is we always show it to you this way. We always show it to you with only 2 things. But how big can it get? Infinite. So, if I have a plus b times x plus y, what happens here is I do a times x plus a times y plus, and what if this goes on? How many a's will I have? As many as what? As many as you need. If this polynomial continues on to the nth, which is just another number, I'm going to continue on to the what? a times n. Everybody understand? Now, you're intelligent young people. You recognize that this distribution can go on forever. I see your hand, Gersil. I'll be right with you. You know that this multiplying can go on forever, yes? Well, then logically, what would happen if I have another whole number here? If the a multiplied all the way through, what will the b do? Multiply all the way through. And I will get a bx plus a by plus ... up till we get to the end, which is a bn. Does everybody understand? Distribution means we take that a and we give it to everybody inside the brackets. Then we do the same thing with b. What if I had a plus b plus c? What would I have down here? What would I have here now? I've done the a's, I've done the b's. What would I have, Jiddu? I'd have cx plus cy plus cn up to the end. Does everybody get it? Okay, so let's talk. Show a picture and an algebra solution. I don't even care if you do the picture. But if you were going to do the picture, one side would be what? What would I draw out here? I draw a single x, right? What would I draw up here? Two x's, and then four little shaded in boxes, right? And then I would fill in the middle. And we're smart kids. It would be that long and that wide, right? And that long and that wide. And then that long, but only that wide. And what wins? Colored or not? Shaded wins. What wins here? Shaded, shaded, shaded. And what is my answer? What do you see here? All you got to do is count, ladies and gentlemen. What do you see there? 2x squareds minus 4x's. And of course, I only am going to make you do it once because really, what do we have? We have the distributive property. The x goes there, 2x squared. Then I go to this one, minus 4x, and I'm done. Right? Great, do the next one. And only do math, please. I don't need the drawing. Yep, see you, Brody. What is the first thing I'm going to get? I'm going to get 3x squared. Then what am I going to get? What I'm going to get is 6x, but what happened was I did 3x times 2 to get 6x. Everybody good? Everything outside has to multiply by everything inside. Jiddu. Of course you can. Okay, let's see if you really get what I'm putting down. What's different here? Binomial, binomial. Factor, factor. Right? How do you know these are both factors? How do you know these are both factors? What math is factors part of? Multiplying. What math is happening right there when there's no sign? Multiplying. So we know we have factors, yes? Where do the factors live in the picture? Outside or inside? Where do they live? The factors live on the inside? They live on the outside. X plus 3, right? X plus 2, right? So what happens when I go this far? How far to the right do I go? All the way out to there, making what? X squared. That long, that wide, that long, that wide, that long, that wide, that long, that wide, that long, that wide. And what's 1 times 1? 1, 2, 3, 4, 5, 6. What is my answer? All you got to do is count. 1x squared, 5x plus 6. Yes? You've seen the picture. Now put it out of your head. Algebraically, x plus 3, x plus 2. Now, some of you have already seen this in the past. I'm going to show you a different way to make it look that makes it, in my 21 years of experience, makes it way easier for you people to do this. If you don't wish to do what I am doing, don't do it. But I'm going to show you anyway. If there was no 3 there, what would you do with that x? It would go to everything. So what is x times x? X squared. And what is x times 2? Plus 2x. Yes? So am I done with the x? Excellent. Now I have a 3. Where will that 3 go? It'll go to the x because it's got to go to everything. Now, do I already have some x's? Of course I do. I'm 44. Do I have some x's? Do I have some x's? Okay. How many more x's do I have now? How many more? 3 x's. I'm going to put all the x's vertically. And then, what do I do with the 3 and the 2? What math is happening right here? So that is 6. Now, it's super easy. What is x squared plus 0? X squared. What is 2 plus 3? 5x. What is 0 plus 6? 6. And then I am done. And you'll notice we have the same answer. Now, every math teacher teaches this with this acronym, FOIL. Some of you have seen it, some of you, all of you should have seen it, but some of you won't have seen it. I don't like this acronym because it only works when it's binomial. Is it possible to have more than binomials? Yeah. So I don't really like this acronym, but everybody uses it. So I'm going to use it once and then never use it again. F stands for first. So I'm going to write out 2 binomials. The first is the first thing you see. A, B. So we have the answer AB, right? That's what we multiply first. The O stands for outside. So I take the A because it's on the outside and I multiply it by the Y that's on the outside over here. So that would be, and remember everywhere you see a plus it can be a negative, right? That would be plus AY. What do you think the I stands for? Inside. Which is these guys. So that's going to be XB. And L stands for last. The last 2 that you haven't dealt with yet. I don't like it because it only works here. But if you like it, you've seen it. So knowing what you know, how are we going to multiply this out? What's the first thing you see? X times X to get what? X squared. What's the next thing you see? Outsides. What are they? X and 4. So how do I do that? That's plus 4x. Inside, what's that? Minus 1x. And I keep my x's together. And last, what's negative 1 times positive 4? Negative 4. And then all I do is gather it up. X squared plus 0 is what? 4 minus 1. 0 minus 4. And I'm done. Can everybody do it?
Yes.
Spectacular. Your job tonight, I lie. I am the worst kind of liar because tomorrow you have a test. Your job for Thursday is to have pages 56 to 57 done. Okay? If you finish your test early tomorrow, what could you do in class? This. What will you do in class? Whisper to my friends and pretend like the teacher can't hear me. Jaden.